Our entire view of the universe, the size and the mass and the contents, depends on this assumption that we can tell distances by redshift. If that one crucial assumption is incorrect, then our picture falls apart and we don't know very much.
Quasars, look at that little tiny dot there on the end of the arrow. That is a quasar, and according to conventional theory, it's superluminous, perhaps as luminous as 1,000 whole galaxies put together, and is more than 10,000 million light years away, and is receding at more than 90% of the velocity of light. Now, how do we tell that? And the answer is by using the spectroscope and the well-known Doppler effect. Remember, a spectroscope splits up light. And when you look at the spectrum of a star, or a galaxy, you see a rainbow background crossed by dark lines, each one of which is due to some particular element or group of elements. Now, if the light source is moving away, its light appears slightly too red. And that means that all the spectral lines are shifted over to the long wave or red end of the spectrum. That is the red shift, and it is absolutely vital because all our distance measures in the far universe depend upon it. Let's go back again to that quasar. Now, how do we know it is so remote and so luminous? Because of its red shift. The greater the red shift, the greater the distance, and the greater the velocity of recession. That's the conventional theory. But that depends upon the red shifts being pure Doppler effects. Now, just suppose there's some other cause of the red shift superimposed on the Doppler effect. And if that is so, if the red shifts are not pure Dopplers, then all our distance measures may be wrong. And one astronomer who believes that and has observational evidence to back it up is Dr. HALTON, ARP, formerly of the Mount Wilson Observatory and now of the Munich Institute. Dr. ARP, we're delighted to have you with us. If you're right, then the effects upon all our thinking are going to be pretty profound.
Our entire view of the universe, the size and the mass and the contents, depends on this assumption that we can tell distances by redshift. If that one crucial assumption is incorrect, then our picture falls apart and we don't know very much. If that one crucial assumption is incorrect, then our picture falls apart and we don't know very much.
Will you give us the observational evidence that you have that the redshifts are not pure Doppler effect or something else superimposed on it?
Fundamentally, the only way you can tell the distance in the universe is to see an object associated with another object whose distance you know. So that if you see objects which are clustered together or are interacting together, you know that they're at the same distance. And if you find that their redshifts are much different, then you know that the redshift can't be a measure of the distance. Now, an example of this we see in this very pretty spiral galaxy with 3 quasars on the edge of it. The quasars have enormously high redshift, and the spiral galaxy has a low redshift. These quasars are so close to the galaxy that they are statistically or probably associated. We see other examples of this. For example, here are 3 other quasars associated very, very close to a galaxy. Now, in addition to these close associations, which are statistically probable, we see quasars actually linked to the galaxy. In this case, the quasar Markarian 205, just below the disturbed galaxy NGC 4319, has a very much higher redshift than the galaxy, which is only about 2,000 kilometers per second. The quasar has about 21,000 kilometers per second. The next example shows a quasar of very high redshift, 1.17, and it's connected by a luminous bridge into a disturbed galaxy with a jet that you can see here. The galaxy is, again, very much lower redshift, and the quasar is a high redshift. Now, not only do we have these quasars of very high redshift linked and associated with lower redshift galaxies, but also we have galaxies themselves of different redshift, which are clearly interacting but have much different redshift. This is a famous example of one of these. There are many like this known now. The central galaxy is a disturbed Seaford galaxy with a redshift of 8,000 kilometers per second, and the companion, which is linked to it, is 16,000 kilometers per second, much higher.
Are you sure these links are genuine? Could it be any kind of line of sight effect?
The only possibility is that there is an accidental projection of background objects. However, these objects fall so close that the probability is overwhelmingly that they are, in fact, associated. One of the objects we just saw, the chances was 1 in a million for an accidental association. Another object we just saw, the chances were 1 in 50,000. and there are many of these known.
In other words, there are too many of these cases to be explained away by line-of-sight effects or just coincidence.
That's right. Statistical investigations of complete samples have shown repeatedly that there are these significant associations. Moreover, they are characteristic of patterns in these associations which are repeated from association to association.
Well, that means, in fact, that the redshifts are not pure Doppler effects, and they're simply not reliable as indicators of distance.
That's right. The only observational test of this assumption that we have shows that the assumption is not correct.
Well, quite apart from that, what about these bridges? How exactly are they formed, and are there any distortions between various systems?
I think a good example is this NGC 4319 object, where you can actually see the luminous connection going from the center of the galaxy to the quasar Markarian 205.
What about the significance of the bridges, then?
Well, I think that the significance is very central here, because the bridge goes back exactly to the center of the galaxy. That implies that the material was ejected from the center, and since it's an active nucleus, this makes good sense. Also, we must remember that it's accepted, and it's been proven, that the galaxies eject radio material, and they eject them in equal and opposite directions, so that it's very well accepted and believed that, in fact, as we see here, for instance, an active galaxy nucleus ejects these clouds of radio material, and in this particular case, there is a quasar associated very nearby. In another example, we see this typical radio galaxy ejecting radio material in either direction, and along the line of the ejection is a compact radio source, which in fact turns out to be a quasar of very high redshift. So that, in fact, we know that galaxies eject material, and the only point is what is being ejected. Now, we can see here, I think, one of the most spectacular examples of ejection. This is a spiral galaxy called NGC 1097, and this color picture shows the long, straight jets coming out from the center of this galaxy. In the next picture, which is a black and white, shows better the contrast in jets. You can actually see a faint fourth jet, again, always the ejection and the opposite ejection, showing luminous ejection of material from this galaxy. But now in this particular galaxy, it's very interesting because there are also radio and X-ray observations. The radio observations are shown here now on the black and white photo. The radio observations are shown in yellow, and they show that the radio material also goes along the line of these ejection of these jets. Finally, the X-ray observations are shown in blue. There are clouds of X-ray material around the nucleus of the active galaxy, obviously ejected from the galaxy, and obviously ejected in the direction of these jets, which are shown here in this picture. But now the really very important and impressive point is that in many of these clouds of X-ray materials, there is a point of light which turns out to be a quasar of very high redshift. These are marked by the X's. And these quasars of high redshift, therefore, are linked to the ejection in this galaxy because the radio material, the optical material, and the X-ray material are all ejected with these quasars. This follows the development of this investigation of groups of galaxies through to the most impressive point, I think. The M31 group and the M81 group are the two groups that we know the most about. The M31 group is our local group. We know all the companions in it. The M81 group is the next nearest group. We know all the companions there. This visual shows that the biggest galaxy in each group is the SB, M31, and M81. And now all the rest of the companions, which everyone has always accepted as being companions, have systematically higher redshift. The chance of 21 out of 21 companions being of accidentally all of higher redshift is only 1 in 2 million. But on the Doppler interpretation, we should have as many coming towards us as away from us, plus and minus. Clearly that's not the case, and clearly this is a point which is just inescapable. There are no future measures that are going to change these redshifts, and we're not going to find any more companions, so we have to deal with this piece of evidence.
What about a galaxy and a quasar embedded in it, or apparently?
Well, that's a very peculiar example. It was first looked at in 1971, and it's a problem that's refused to go away. What we see, if we look at the main galaxy in this false color image, off to the right of the main galaxy is a little blob, which is a quasar Markarian 205. Now, it's got a redshift 10 times greater than the main galaxy, and yet it seems to be connected to the galaxy by a bridge of material. Now, a lot of astronomers have looked at this. Some maintain the bridge doesn't exist. Some maintain it's a photographic artifact. Others that it's due to a convenient interposing galaxy that makes the connection. But Jack Silentix looked at this, and he's quite convinced that the connection is real and can be traced into the heart of the main galaxy. If that's true, and the redshifts differ by a factor of 10, then the whole redshift business has got a major problem.
It really is a problem. Well, you're certainly painting an entirely new picture. How do astronomers in general view it?
I think that, that there's a great commitment to the assumption that redshifts always mean velocity. And there's a great reluctance to give up this assumption because a lot of work has been based on it, and there is this reluctance to recognize evidence which contradicts this assumption. However, if it's true that the redshifts are not always indicative of velocity, and it's continued to be believed that it is, if this assumption is continued to be believed, then we reach a very critical point in the science of extragalactic astronomy. And this is so important that I think that everybody, every person then has to make up his own mind, exercise his own judgment on this matter, and therefore I think it's very important to discuss the facts of the matter as we have here. And this particular spiral galaxy we see here, we see that there is a disturbance in the top, in the arm at the top, and if we look in more closely, we find a very peculiar blue object associated with that spiral arm. And if we take the spectrum of that object, we find, amazingly, that it has a redshift 1/10 the velocity of light, an enormous discrepancy. This reminds me of the remark that Sir James Jeans made more than a generation ago when he suggested that spiral galaxies perhaps were the place in our universe where matter was poured in from other universes.
There's no inside structure.
Is it hollow?
Yeah, there's only a surface. There's nothing inside.
Is the sun actually, do you believe, combusting it out of
It's
itself?
not burning anything. There's no fusion in the sun. That's well understood.
Prove it.
Yeah, well, there's no way to prove that there is any. It's only in the flares that you get fusion. That's why all the X-rays. Flares, the arcs, and the X-rays, and the microwaves, and whatever result of fusion in the arcs. There's no fusion in the sun. They don't know how the sun works.
Why do you? What's special? How does the sun make light?
It's a transformer. Transforms from some other dimension. It's not burning anything. It doesn't have to. It's a converter.
Of what?
I don't know. Nobody knows. But that's what it does. That's the only thing it can do because that's how everything works.
Transforming from another dimension?
Yeah, you could say it's taking energy from another dimension, counter space.
This reminds me of the remark that Sir James Jeans made more than a generation ago when he suggested that spiral galaxies perhaps were the place in our universe where matter was poured in from other universes.
For the heresy of opposing orthodox interpretations of the redshift problem, ARP has had to pay a heavy price, the same price paid by many a scientist with new and innovative ideas. Dr. ARP was forced to resign from his permanent position at the Carnegie Institute of Washington Observatories after the Caltech head of the Telescope Allocation Committee threatened him by saying, unless he changed his line of research, they would take away his telescope time. Due to this fact and his ongoing struggle against the established paradigms, ARP is often referred to as the modern Galileo.
I remember when I sent the paper into, the first paper into Astrophysical Journal on the nature of companion galaxies, and I had a lot of them on the ends of spiral arms, so I was sure that they were connected, and I showed that they were systematically redshifted. I sent that in with naive, great expectations that people would be terribly interested and impressed on this. And the editor of the Astrophysical Journal at that time was Subrahmanyan Chandrasekhar, who had a fantastic reputation as a master theoretician and also quite an incomprehensible theoretician, and a tremendously powerful figure in the field, and editor of the Astrophysical Journal, which is probably the most powerful position in the field. And he chose not to, in his wisdom and judicial fairness, chose not to send it to a referee, but he just wrote across the paper, "This exceeds my imagination," and he sent it back to the director of my institute, Horace Babcock, with the obvious implication: you've got to do something about this staff member of yours who's doing these very bad things. And so Horace called me down in the office one day after this, and I walked in his office, into the director's office, and I saw this paper lying in front of him with Chandrasekhar's scroll across it. And Horace looked at me and said, "Well," he said, "this is just too much, and you're going to have to start looking for another job." And so all I could say to him was, "Well, if you send me that in writing, please send me in writing." And I was waiting in great trepidation for weeks and months to get something in writing, and I finally never did, so I realized that he decided to give me another chance, so to speak. So that was fairly early in the game, and then some years went by, and there was the competition for time, particularly on the 200-inch telescope, was getting more and more heated, and people were saying, "Well, we can't continue to give time to this obviously incorrect and embarrassing research that ARP does." So finally they sent a letter to me from the allocation committee, including a number of the younger members of my institute, saying that unless I changed my line of research, that they would have to take away my telescope time.
Giordano Bruno, was burned on the streets of Rome for daring to question the place of Earth in the cosmos. Now, thank God I haven't been burned at the stake, but is it possible that we still have questions that we're not allowed to ask? Have we come full circle to the point where we're not even allowed to ask the question anymore? Could Earth be the center of the universe? What would it mean for our view of ourselves, our culture, our destiny? What would it mean if it were to turn out that we really are special? If we've reached a point where that question cannot even be asked anymore, then we have a bigger problem than I ever would have imagined. It is my sincere hope that no matter what your personal views on this may be, that you will insist on the right of filmmakers and other artists and investigators to ask even the most controversial, even the most uncomfortable question